action. Okay, here we are with 4.3, the addition method. And as I mentioned in class, we're going to be doing these vertically. Look at these vertically. Our goal is to get one of the variables to be opposite of each other, so when we're adding them vertically, it will be 0. And then we can deal with the one variable to solve for. So here I can see the y's are opposite of each other, of course, in number 2. We're starting easy. This is, they are opposite, so I'm just going to add these x's going down, which will give me 6x. Here my y's are 0. I'm not going to write anything, and it's going to equal 13 plus 5, which is 18. Of course, get the x by itself. We'll divide both sides by 6. And I'm going to have x equals 18 divided by 6 is 3. Okay, so we've got x is 3, but now what is y going to be? So just plug in 3 for the x in either one of these equations. Maybe this one will be a little easier. So it's going to be 2 times 3 minus y equals 5. Alright, so this is 2 times 3 is 6, so I'm going to subtract 6 both sides. And I've got negative y equals negative 1. So therefore, y equals 1. So my solution set becomes 3, 1. Okay? And these are supposed to be braces, or, yeah, braces. Alright, so there's number 2 of the first of several exercises. Okay, how about number 6 here? Looking this over, I see I can get, probably a little easier to get the y's eliminated if I were to multiply this whole top equation by 3. Now I'm projecting 3 times y is 3y, then 3y minus 3y is a 0. So that's what I'm going to do. But I have to multiply each of these terms by 3 using the, we'll call it the distributive property in a sense. Got to multiply all 3 of these terms by 3 so I don't change the problem. So I'm going to have 3 times 4x is 12x. 3 times y is the positive 3y equals 3 times negative 13 is negative 39. Okay, so now here is my system with these two equations here. Distributed this 3 to the top equation, it became this bottom equation. Now I'm going to combine these two equations here. So that gives me what? 18x. This is my 0, that's good, equals this here, what they're both negative, so what I got 4, negative 54. Okay, divide both sides by 18. And x equals negative 3. Okay, 30, 40, 50. So now we got to figure out what is y. What is y? So I'm going to go back and I'm going to, since I distributed the 3 over this top equation, I'm going to pick on this second one. And that's going to be what? 6 times negative 3 minus 3y equals negative 15. A lot of negatives going on here. Okay, so here I've got negative 18, so I'm going to add 18 to both sides. Here I've got negative 3y, that equals 3. Divide both sides by negative 3. I'll do it this time. And y is going to equal negative 1. So here's my solution set, negative 3, negative 1. That's it. another system. Notice on my systems I don't put this here, you know, that, what was it, that brace. I got numbers to work with, so I don't want to clog it up. I just leave it off, so you know what you're doing at this point. Alright, so what am I going to do here? I'm going to multiply the top equation here by, looks like -5. I've got my eyeball on the x's to cancel out. Alright, so if I multiply this top equation by -5, it's going to be -5x minus 20y, and that's going to equal -5 times 20 is 70, -70. Okay. Now bring things down here. I've got 3y minus 20y is -17y. That equals -68. Okay, kind of odd numbers, but divide both sides. Divide both sides by -17. And therefore y is going to equal, what is that, 4? 50, 68, yeah, so y equals 4. Alright, bring this guy out here. Y is 4, so that's going to be 5x plus 3 times 4 equals 2. 3 times 4 is 12, so I'm going to subtract 12, both sides, and I'm left with 5x equals -10. Divide both sides by 5, and x equals -2. -2, 4 is my solution set. Okay, number 14. Think about this one. My eyes are attracted to the y's here to clear out, so that means I'm going to multiply this top by -3. But I also see something strange happening. Let's see, I'm going to distribute this. I see -3y plus 3y will give me my 0, so let's go ahead with that. But I also have -9x minus 3y. That equals -12. Okay, so in my head I'm thinking, oh, these are going to be gone. They're going to be 0. So I'm going to end up with 0 equals -6. Okay, and what does that translate to be? No solution. Okay, no solution for that one. If it were true, it would be many, infinitely many answers, but it's false. Another one. How about the top? Top, I'm going to multiply by -2. So I'm going to have -2 times 2x is -4x. -2 times y is -2y. So we got that same situation going on here. -2 times 6 is -12. However, in this problem, we're going to end up with 0 equals 12 minus 12 is 0. So here we end up with the true statement, which is not the answer. The answer is what? All real numbers, perhaps? Or infinite? However you want to say that. You know, many solutions is fine too. So either one is sufficient. But more importantly, to recognize that and what it means. Okay, here's the next one, number 22, where we have a problem. We're not going to just be able to multiply a number times one equation. In problems like this, we got to multiply the top by a number and the bottom by a number to create opposites in either the x or the y's. When this happens, I always pick on the x's to be opposites because, I don't know, I just like working in the front better. So what I'm trying to say is I'm going to multiply the top equation by the coefficient of the x in the bottom equation. So that's going to be 3. Then I'm going to multiply the bottom equation by the absolute value of the top equation in this case here, which just means 2. Because then I can see I've got -6 here and +6 on the bottom. So you got to think that through and sort it out in your head. What is happening with that? All right, so translate this over across, and it's going to be what? -6x plus 9y. That equals 30. Okay. The bottom equation is going to be translated to be 2 times 3x is positive 6x plus 8y. That equals 4. Now I can go ahead and draw my line because I see my opposite x's here, which is 0. This is going to be 17y equals 34. Dividing both sides by 17, y equals 2. Okay. Go back up to the original set of equations here and take one of them. Doesn't matter. I'll take this bottom one here. And if y is 2, this is going to be 3x plus 4 times 2 equals 2. Okay? This is 4 times 2, which is 8. I'm going to subtract 8 from both sides. Gives me 3x equals -6. Divide both sides by 3, and x is -2. -2. 2 is my solution set. Okay, isn't that fun? What was that, number 22? All right, go on to the next problem. Number 24. Here we go here. And how about I get these guys to be the same, or which one? Well, I said I picked on the x's. It would be easier for the 3 and the 4y, but I'll do the x's like I said. All right, so this means the top I'm going to multiply by 12. The bottom I'm going to multiply by 9, but one of them has to be what? One of them, in this case, has to be negative. So I'm going to pick on this to be negative. The top one. Doesn't matter which one, but that's the one I'm choosing. All right, so now when I multiply this through, I've got -12 times 9x, which is -108x, plus negative times a negative is a positive 36y. That's going to equal -12 times 12 here is -144. Okay, I'm happy with that so far. Let's go to the 9 and distribute that across. And that's going to be positive 108x minus 36y. Are you kidding me? 9 times negative 4y is negative 36y. All right, that equals 9 times 18. What is that? 9 times 8 is 72. And that's 162. Okay. I see it. So this is what? 0, 0. So 0 equals a number here. I know that's not going to be 0 there. So if let me do it up top here. That's 8 and 18. So 0 equals 18. That statement is false. And that means this answer is no solution. There is not a set of numbers, x and y, that will satisfy both those equations. All right, so there it is, no solution. Okay, and problem number 34, we've got a couple of things going on here. First of all, this top equation's a mess. So one thing we have to do is we have to align these to be in standard form, ax plus by equals c, both equations. So let me straighten, let's do something here. Let's get them in the right order here first. So I'm just going to distribute this across just to make it in more the standard form. So I'm going to have negative 9x, and it's going to be minus 27. That equals 8y. Okay. And then this 3x minus 3y equals 8. That's fine. So let's see. I want to put this in ax plus by form, so that means what? I have to subtract 8y on both sides here. Subtract 8y. I'll just throw it over here. And add 27. I'll do it at the same time. And when I do, I'm going to have my negative 9x, now my minus 8y, that's going to equal positive 27. Okay? Now this is in standard form, and if we want, we can bring it over here. Rewrite it to be negative 9x minus the 8y, that equals 27. And here is my new system right here. I'll write my bracket out here. Okay, so this is what's new. And now I can go ahead and solve this system. And it looks like I would multiply this top equation by 3. Projecting 3 times 3x is 9x, and 9x minus 9x is a 0. And I'll see what happens later the rest of the way, but it looks like it's clear sailing. So 3 times 3x is 9x. 3 times negative 3y is negative 9y. 3 times 8 is 24. Using these two equations now, draw my line. 0, negative 17y equals, what is that? 51. Dividing both sides by negative 17, y equals negative 3. I like. All right, if y equals negative 3, I can come up to the top one or this one to solve it the rest of the way. All right, let's get cute here and pick out this equation. Since I know what y is, let's bring it down here. And that's going to be what? I'm going to distribute that since I can see it clearly. Negative 9x minus 27 equals this 8 times negative 3, because that's what y is. Okay, here I'm going to have negative 9x. No, what am I doing? Not yet. I've got to add 27 first. Add 27. Hope you don't mind me taking a little shortcut there. Here I've got negative 9x. Now I'll bring that down. I'm adding 27 to both sides, but what's happening here? This is negative 24 plus 27. Simple arithmetic, right? And that's going to give me 3, positive 3. Divide both by negative 9. So x equals negative 1 over 3. And these are my solutions to that system. Okay, so if I plug these into these equations, it should work. So now I'll plug them both into this one. This was one of the original here, right? So it would be what? 3 times negative 1 over 3, because that's what x is, minus 3 times negative 3. Good with that? Equals 8. All right, 3 times negative 1 over 3 is negative 1 plus 9. Negative 3 times negative 3 is plus 9 equals 8. And that's true. That's it. So I just verified it. Confirmed it. All right, one more problem to go. Okay, here's a toughie. Here's a tough problem. A lot of things we can do with this to make it easier, but let's just clear these fractions out first of all. All right, let's see. So between LCD of 2 and 4 is 4, so I'm going to multiply everything by 4 for this top equation. And that's going to make it, let's see, what will that make it? I hope I got room. 12x plus 14y equals 3. All right, in the bottom, we'll clear these fractions out by multiplying everything by, let's see, between 2, 3, and 4. Looks like 12. 12, 12, and 12 over here. All right, so the first term, this is going to end up being negative 6x. Don't forget your negatives here. Plus 20y. And that's going to equal 15, negative 15. Okay, so here's my system now. These two guys here. Agree? Okay, so now I can get rid of that. So here I'm going to multiply this bottom equation here by, let's say we do it by 2, right? 2. Because the x's will cancel out then. So let's see, 2 times negative 6x is negative 12x. I'll write it underneath here. Plus 40y. That equals negative 30. So this guy here is gone, and I'm concentrating on this bottom equation and the top one to combine vertically. So you can scratch it out sometime too if it's bugging you. So 12x minus 12x is 0. 14y and 40y is 54y. that equals 3 minus 30 is negative 27. Oh, that's good, because 27 is half of 54. So this ends up being negative 1 over 2. Okay, what is that? Y. Y equals this. Okay, good. I'm happy with that. So I could take this and bring it over to one of the original. I could bring it over to this equation here if I wanted to, and plug it in, since we just multiplied everything by 4, not changing the problem. So let's try it. Or I could plug it in here, which might be a little more exciting. Okay, let's try which one? Let's try this top one here. So I've got y. I'm looking for x. So it's 3x plus 7 over 2 times negative 1 over 2. That's what y is. Equals 3 over 4. Okey-doke. So this becomes, let's see, 3x, and this is going to be negative minus 7 over 4. Negative 7, and 2 times 2 is 4. That equals 3 over 4. Okay, let's see. Oh yeah, I got plenty of room. So here I'm going to add 7 over 4 to both sides. Add 7 over 4. And that gives me what? 3x. That equals 10 over 4. Okay, so here I'm going to, what can I say? If I divide this by 3, or let's say I'll do something different here, something a little more understandable, I think. Rules of algebra says what I do to one side I can do to the other, I have to do to the other. What if I multiply this by 1/3? And this multiplied by 1/3? Then I know this left side is x by itself. That equals 10 over 12. 10 times 1 is 10. 4 times 3 is 12. Which simplifies to be, what goes into, what is this? 2 goes into 10 5 times, and 2 goes into 12 6 times. And x equals 5 over 6. X equals 5 over 6, and y equals negative 1 over 2. So there's my system. If I plug it in again to the, I'll do the other equation, which is, which one do we do now? How about we do this bottom one? If I can see that. Hope I don't mess up the signs here. If I do that, let's see, I've got x is that, negative x over 2, which would give me, this is like saying negative 1 over 2 times x, which is 5 over 6, plus 5 over 3 times y, which is times negative 1 over 2. And that has to equal this negative, move it over, negative 5, I'll put it out here, negative 5 over 4. That's what this has to equal here. So let's try it. Negative 1 times 5 is negative 5 over 2 times 6, which is 12. 5 times negative 1 is negative 5 over 3 times 2 is 6. Okay, so I'm going to multiply top and bottom here by by 2, not 6, 2 over 2, get my denominators to be the same. So that would be negative 5 minus 10 is negative 15 over 12. Simplified, 3 goes into negative 15, negative 5 times, and 3 goes into 12, 4 times. So we just verified that, validated it, our answer for that one. Tough problem there. All right, that is it. I thank you. We thank you here at the college, and see you in class.